Look at any screen today, and you'll see an ecosystem entirely built to capture one finite resource: your attention. Every notification, glowing icon, and autoplay video is competing for limited space inside your head. The issue is that the human mind evolved for a very different environment. We simply aren't biologically equipped to process an endless, overlapping flood of digital information at the exact same time. We like to think we're good at multitasking, but in reality, we are doing something called split attention. Instead of handling multiple inputs simultaneously, the brain rapidly toggles its focus back and forth between tasks. Every single time that attention shifts, the brain has to hit pause, refocus, and rebuild the mental context from scratch. That constant context switching burns glucose, wastes energy, and leads directly to mistakes. So splitting your focus doesn't make you a more efficient worker. It systematically drains your cognitive capacity and speeds up mental fatigue. To understand why certain tasks crash our focus, we have to look at multiple resource theory. This tells us the brain processes information using distinct, separate systems, like visual, auditory, and motor networks. You can easily listen to music while walking because hearing and leg movement use different mental pathways. But when two actions compete for the exact same resource simultaneously, performance drops sharply. Consider someone trying to drive through traffic while having a phone conversation. Even if this driver's eyes stay glued to the road, the system gets overwhelmed. Navigating traffic and constructing verbal responses both heavily monopolize cognitive attention. The brain simply runs out of bandwidth. This chart models the Yerkes-Dodson law, mapping human performance against stimulation and stress. You can see how optimal performance happens right in the middle, where we are highly focused but not yet overloaded. Apps use reward loops and notifications to provide the stimulation needed to pull a user out of the boredom zone on the left. By balancing these alerts with low-friction interactions like infinite scrolling, they keep the user's mental workload high enough for engagement, but just below the threshold of stressful overload on the right. The modern attention economy relies on managing these human stress responses, carefully converting your continuous focus into a commercial product. To navigate this external digital flood, we rely on a specific internal architecture to process data. It starts with sensory memory. This is an ultra-short-term filter that handles the continuous stream of physical and visual inputs, like noticing a sudden movement in your peripheral vision or retaining an image after looking away. If that information is important, it moves into working memory. Think of this as the brain's active, temporary workspace, the area you use for immediate problem solving, following GPS instructions, or holding a phone number in your head just long enough to dial it. But working memory is extremely limited. Psychologist George Miller famously found that humans can only actively manage about 7 chunks of information, plus or minus 2, at any given time. This is a stark contrast to long-term memory, which boasts massive storage capacity for learned skills and past experiences, even if retrieving those memories can sometimes be imperfect or fuzzy. Because of that severe size limit, working memory acts as the ultimate structural bottleneck in all human-computer interaction. If an app or website demands more active memory than a user possesses, confusion sets in, and they will simply leave. The absolute measure of mental effort required to navigate an interface is known as cognitive load. The brain's primary defense against high cognitive load is chunking. Instead of memorizing 11 numbers individually, the brain naturally groups them into 3 distinct blocks, bypassing the strict limits of working memory. This happens because humans generally struggle to summon complex information out of thin air. Forcing a user to manually recall a specific command or sequence from scratch demands a huge amount of mental energy. We are much better at recognizing things than recalling them, relying heavily on visual cues. The stark red background and distinct typography of these mailers instantly trigger a connection to your long-term memory, instantly communicating purpose without active cognitive effort. The most successful interface design intentionally offloads this mental work from the user. It relies on structural chunking and familiar visuals, so the brain doesn't work as hard. How the brain naturally organizes this visual chaos is explained by Gestalt psychology. It is the visual grammar of the human mind, an automatic, built-in drive to search for structure and relationships in everything we see. Through proximity and similarity, the brain groups objects together based on their placement and appearance. Buttons grouped together, or icons sharing identical colors, are instantly perceived as connected systems. Then there is the law of simplicity. The brain prefers a straightforward, minimal interpretation. When an interface embraces vast white space and strips away clutter, it requires fewer mental cycles to process. A simple environment correlates to lower cognitive load. We also naturally follow lines and curves, a concept known as continuation, which is exactly why scrolling feeds guide our attention continuously downward. Through the law of closure, our brains automatically fill in missing visual gaps in minimal logos. Good design feels intuitive because it matches how the brain naturally processes and groups visual information. The human hardware we run on is incredibly powerful, but it operates with strict limits on single-thread attention and restricted working memory. When interfaces are engineered without respecting those limits, the results are user anxiety, severe cognitive overload, and ultimate product failure. That brings us to the next phase of human-computer interaction: cognitive-aware systems. Future AI environments will feature adaptive interfaces that can dynamically shift and simplify their layouts based on a user's real-time mental workload. Building technology that operates within these psychological boundaries allows for more efficient collaboration, creating systems that accommodate human thought. If you found this breakdown of cognitive design helpful, hit the like button and subscribe for more deep dives into technology.